Hello, my name is Davis Binger, and let's talk about improper integrals. Today we will be performing problem 7 of the 7.8 handout, in which we will determine whether the improper integral, the integral from 2 to infinity, of negative 2x plus 6 divided by x times x squared plus 2x minus 3 with respect, converges or diverges. In the event that it converges, we are additionally asked to find its value. The integrand of the integral in question is a rational function. As such, it needs to either be elementary enough that we can take its integral already, or we will need to use partial fractions decomposition to rewrite this rational function as the sum of rational functions for which we can take a simple antiderivative. Now in this case we will need to perform partial fraction decomposition. Our denominator is x times x squared plus 2x minus 3. This factors into x times x plus 3 times x minus 1. Thus we have a general form for our partial fraction decomposition which is a over x plus b over x plus 3 plus c over x minus 1. Alright, our first job will be to find these constants. So we will take the expression at hand and we will multiply by the denominator, after which we arrive at the expression negative 2x plus 6 is equal to a times x plus 3 times x minus 1 plus bx times x minus 1 plus cx times x plus 3. We can plug in various values for x to find a, b, and c in this expression. Our strategy will be to plug in values of x for which only one of the unknown characters survives. So for example, if we plug in x equals 0, the term bx times x minus 1 is equal to 0, and the term cx times x plus 3 is equal to 0. However, a times x plus 3 times x minus 1 is not. So by plugging in the value x equals 0, we can find the constant a. In this case, the left-hand side is equal to 6, and the right-hand side is equal to negative 3, a. So dividing by negative 3, we find that a is equal to negative 2. Alright, so we are now trying to find b. The value x equals negative 3 will cause the term associated with a to be equal to 0 and the term to be associated with c to be equal to 0. So we will plug in x equals negative 3. The left-hand side evaluates to 12, and after sum algebra, the right-hand side simplifies to 12b. So dividing through by 12, we find that b is equal to 1. So to find c, we will plug in x equals 1. At x equals 1, the left-hand side simplifies to 4, the right-hand side simplifies to 4c. After dividing through by 4, c is equal to 1. Thus we have performed partial fraction decomposition for our integrand, and we can proceed with solving the improper integral. Now we rewrite our improper integral from 2 to infinity as a limit of proper integrals. The limit as b goes to infinity of the integral from 2 to b of our sum of rational functions with respect to x. Now each of these simple rational functions has a nice antiderivative. Negative 2 over x integrates to negative 2 log x. 1 over x plus 3 integrates to x plus 3. 1 over x minus 1 integrates to log of x minus 1. We will evaluate this expression from 2 to b and then take the limit as b goes to infinity. For doing so, let us take a moment to simplify this expression. We'll remove the absolute values as we are dealing with all positive values, and we will combine the logs into a single expression. So notice that the negative 2 log x contributes an x to the negative 2, and the log x plus 3 is in the numerator and the x minus 1 is in the numerator due to the positive constants associated with these logs. Now we have simplified the expression. We can evaluate it from 2 to b and take the limit. By the continuity of log, we can exchange the limit and the natural log, and thus we are left taking the limit of a rational function. Recall how you take limits of rational functions. You assess the degree of the numerator and compare it to the degree of the denominator. If the degree of the polynomial function in the numerator, that is the top, is larger than the bottom, it will grow faster. Think about the rational function x squared over x. X squared grows much faster than x, so the entire expression goes to infinity. Whereas x divided by x squared, this is the case where the degree of the denominator is greater than that of the numerator, will go to 0. In the case that the degrees are equal, maybe x squared plus 1 divided by x squared, the limit will be the ratio of the coefficients of the lead terms. In our case, the degree of the numerator, after we do a little bit of algebra and take the product of b plus 3 and b minus 1, will be 2. And the lead coefficient will be 1. And so the degree of the top is 2, the degree of the bottom is 2, the ratio of the coefficients is 1, thus the limit is 1. So our expression is equal to log of 1 minus log of 5/4. Log of 1 is equal to 0. So this is just log of 4/5. Remember that if you take the negative of the log, it's the same thing as taking the log of the reciprocal. Alright. Thank you for watching. And as always, you can reach me by leaving a comment below or by emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.